Hi, welcome. All right, today we're going to go through a review. So, exam on Tuesday. So, exam 2 topics for Tuesday. Remember, the exam will be in the same room, Ingman Lab. It will be the same format as it was last time. So you need to be in person. Make sure that you're uploading your work. If you have questions, if it uploaded correctly, you can put as a comment after you've uploaded the work. You can put a comment on the exam 2 and actually add it as an attachment at that same exact time. So if there's any questions about did it upload or not, you can also make sure that you just attach it, and that one you can see for sure that it's there. So exam 2 topics: identifying the op-amp configurations, being able to either design an op-amp or analyze an op-amp configuration to determine what the output is based on an input, or design it to be able to create that. Determine solutions for a first order linear circuit containing a capacitor and an inductor, so what we went through last time. So that also means that you have to understand the characteristics of a capacitor and an inductor to be able to do that solution. All right, questions about what will be on the exam?
When is it?
Tuesday. This coming up Tuesday. Yes. So next Tuesday. Next time period.
As in like a couple days from now, right?
Yep.
Oh.
Yes. And I just realized I don't think I opened up the quiz for you guys. That is due tomorrow. Because, we're Thursday. Okay. So I'm going to extend. The quiz will probably be available tomorrow and due on Saturday. Or due by Saturday, yes.
Just because we only have time from Tuesday to Thursday to do it. So
I'm seeing lots of yes, please. I don't think it's unreasonable to ask, so yes. He's sitting there laughing at you, but I will reconsider reasonable requests. So yes, Sunday. So Unit 2 practice is going to be the best thing to keep going over extra problems. So practice as many problems as you can. So that's my suggestion. Make sure you go through as many Unit 2 practice problems as you can. And that will help prepare you for the exam. All right, any other questions, comments, concerns? Okay. 2,200 students that are here just half the semester. You will be done with the content after this exam 2. So you will not need to attend again after exam 2. Okay, so identifying op-amp circuits. So remember, for identification, you have to first look at how many inputs are there. Actually, before that, is it a switch or is there feedback? Let me go back to where I put all those op-amps. Remember, I had a summary of these. Let's see, 9 updated. Okay. So how many inputs? Is it a switch or a feedback? If it has one input, then you have a non-inverting, inverting, and you have to look at which terminal it goes into. For 2 inputs, you're going to have a non-inverting summer, inverting summer, or difference op-amp. So looking at, does it go into the positive, does it go into the negative, or do you have signals that go into both? So that's how you're going to identify these. So that's kind of the summary of looking at the different configurations. So looking at this, take a second to determine, what configuration is this? All right, good. So everybody seemed to be at a consensus. So it is non-inverting. It does have feedback. The feedback comes back through here and goes to the negative input. So there's your feedback. And then there's one input that's basically coming in from here. And that goes into the plus side, so it's non-inverting. So a non-inverting amp. So good job. All right, let's look at these two. Let's first look at this one, the AD620B. Up here. Let me call this 1 and this one 2, and actually identify both of these, what kinds they are. Yeah. Yeah, so they're just different names for the same circuit. Subtracting the difference.
What is going on with the wire that goes into the first op amp halfway up and then just disappears? There's just 6 wires going into the first op amp. I think I want to say none of the above. Okay, so this is the first op amp, right? So it has positive and negative input voltages going in, and there's a third wire going in this stuff.
I'm guessing that's just ground.
No, because look, it goes. Why is there like? This is the ground.
Okay, this has stumped a lot of you, it looks like. So on these, you look at where the output is, and the output here, do a yellow. So the output comes to this wire here, output. But then it looks like, okay, it goes up, but it goes up and it goes through to just a 5-volt source. So there's not a pathway there back to one of the inputs. So this is going to be a switch. So this is a switch and not, so the purple wire and the green wires are to supply it. Those are going to give it the supplies to be able to turn on the op amp. But they're not any pathways back to the input there. So that one's a switch.
Why
Yeah.
is there 2 wires on the bottom side there? Is that just 2 supplies?
Uh-huh. So it's just giving you, it's both grounded, but it's a way to actually offset your output, and so it just has a different functionality. So it gives you an extra option there. In this case, they were just both grounded. Yes?
Resistor on the side of the, it doesn't feedback to any. Like, that says G equals 100 and orange 99.
So this is, G is for gain. So this is a resistor can be put there and actually modify the internal gain of this op amp. So we have always assumed it's a really high gain, but this one will actually let you fine tune it even more to be more of an exact value. So it's just an option for this op amp in particular. All right, other questions? Okay, so this one would be, a switch would be your answer. On this one, again, you have the supplies, the purple and the green. Again, they're just supplies though. There's no pathway because this goes to ground. So this is all, sorry, there you go. This is all ground there. So there, again, is no feedback from that output back into one of the inputs. So this is also a switch. All right, questions on that? Yes?
So it doesn't follow back into the
No, because it just goes to ground.
Okay.
So if it goes to a source, that source is setting it, it's not going to be feedback. It's like it's just being set up to a battery. All right, other questions? Yes?
Does it have to affect this on the resistor on the negative side? I don't quite
So in order for it to be any of the other configurations, it has to have feedback where it goes from the output back to the input. If it goes to the output in a battery or ground, which is the case here, then it doesn't have, it's not going to have any feedback going back to the beginning or back to any of the inputs. So up here, you can see, like, yes, there's a feedback that goes through some resistors back to the negative, or it needs to be at least one wire that goes back to the negative side. Do you see the difference there? Okay. Let's see. Okay, so for example, this op amp. So this op amp right here, the output you can see becomes the input of the next op amp. But there's no feedback from that location back to any of the inputs. So this one would be a switch also. This A1 would be a switch. Yeah, whatever that A is. This one, the output comes here, and then it does come back to one of the inputs through a capacitor. So this would have, this is an integrator or differentiator because of the capacitance in there. but it has feedback, so it's not gonna be a switch. Okay? I won't ask you that one without the capacitors. Okay. So this is not a switch. So not a switch there. So it does have feedback, but you just don't know what it is because it's a capacitor in there. Okay. Which one do I want to do? Okay, let's look at this one. I'll call this 1. Do note this one's already labeled. This one is a comparator. And let's do this one too. So for 1 and 2, determine what those are. Yep.
But I think there's a voltage source. It's a, or a,
saying that's ground.
yeah, there's a capacitor, there's a charge capacitor.
Okay, wait, there's a ground symbol and then it says ground.
The one definitely has a voltage.
So this is a new one for me, a mom inverting summer in a comparator. Like so the capacitor, you don't look at it as a voltage source. What it's going to do is create a passage or removal of different frequencies. So that actually ends up being a filter, is what that. Awesome. So it filters, so it doesn't change. Like this is still going to be a. So that's actually a buffer over there. Yeah, on the far right, that's actually going to be a buffer voltage follower, and then the capacitors in there are going to create which frequencies are actually going to go through to it. So it's called a high-pass filter, and it will pass frequencies above a certain value. So this one is going to be a inverting amp. Inverting amp. Is there any questions why that's an inverting amp? So here you have to see like, okay, this is probably my input. It's kind of questionable what's going on with 5. And this gives you a clue that this is your ground reference. So that's actually acting as kind of your reference of ground there. So that would be an inverting amp. This one is a voltage follower or buffer. And that's being used to actually create that reference ground that the rest of the circuit is using. So that one's a follower. So your pathway's here. This is your pathway back to the input. Here you have the pathway here, and then you also have the connection into your input there. All right, questions about why those are?
How do we address capacitors in circuits?
I won't ask you ones with capacitors in there. So, yeah, I won't give you ones with capacitors in them. So it's a little bit more information that we need to go over to be able to analyze those. Yes?
How do we address the difference with the ground reference and then the ground symbol? There's also like ground symbols for the first one.
You mean like this one, or what do you mean?
There's talking about like on the first op amp. There's one like connected to the -9 input, but then there's also the ground reference. So which ground do we trust?
So what that ground reference means is and it says there it's 4.5 volts. So it's just a reference ground, and it's comparing everything to 4.5 instead of to 0. So, when we've looked at node voltages, we say, okay, we're comparing them to 0 to that point, and then we say it's 4.5 from ground, like from 0 volts. Here it's saying it's using that as another creation, and it's basically shifting everything from 0 to 4.5 volts. So it isn't actually a ground. So how do I describe this? The input would go, this would be acceptable to say like so what it's doing here is it is a subtraction. Or difference amp would also be okay to save for this one, because what it's doing is it's taking the input signal and it's subtracting off 4.5 from it. It subtracts off the 4.5 volts. Well, 4.5 with the gain of 1 meg over 1K is 6.3, so 3, so 1,001, because it's a non-inverting gain for that side. But it's taking that and just subtracting it off. So you could say here this is a subtracting difference would also be an okay thing to say. So either of those answers I would have accepted. All right, other questions? Okay. Okay, so, what happened to the, okay, this was supposed to have one more problem on here. Let me go back and find it. Okay, so I apologize, for some reason it deleted this page. So this is where you're going to have to find the output in terms of V1 and V2. So to do this, you're going to have to identify what each op amp is and then determine what the gain is for each one of those. So go ahead and work on this. Grab. So trying to find V out in terms of V1 and V2. So finding those values that will be there.
No, B2 is -3 divided by 3 -1 plus
What? You gotta fill
six divided by 6 and all that's divided by 1,000, so it's 1/1,000. Because those are very heavy. And you have a gain of 3 going in. Divide that by so then, so you have negative 0. Let's go away. It is. It assumes
All right, so the first one on the top left is going to be inverting. This one's going to be non-inverting, and then you're going to have a non-inverting summer. So the inverting, you're going to take the 6K divided by 2K, and that's a negative, so negative 3 times V1. The non-inverting is going to be 1 plus the 5K over 1K for 6, so 6 times V2. So those are going to be the values that are going to be on those wires. Therefore, does this 3K alter that value at all? So basically you're going to ignore that. That one doesn't factor into any effect on those. What about the 1K here? It doesn't affect it either, and this 1K doesn't affect it either. From this one, you can go back to the equation for the non-inverting summer, which is this one. So you have to identify what are those values. So in this case, this will be, V out will be 1 plus 8K over 2K times this one, which is 3K over 9K, times the input there, which that input is a negative 3V1. So that's a negative 3V1 as the input there, and then plus 6K over 9K times that input, which is 6V2. So this gives us 1 plus 4, 1 over 3 times minus 3 over V1, or minus 3V1, plus 2/3 times 6V2. So V out will be 5 times a negative V1 plus 4V2 for negative 5V1 plus 20V2. Sorry, there we go. All right, questions about how to do that? Okay. So Unit 2 practice has more of these. So you can go and practice on those. All right, any questions before we move on from the op-amps? So these are the kind of questions you're going to see: identifying the op-amp configurations, either being asked to identify or design, like what would this value be for this resistor to give you this particular gain, which is some of the questions you've seen, or it could be asking you for these cascaded op-amps. So with this one in particular, you do need to identify what resistors affect the answer and which ones don't. So what is this 7K? Is that changing? If I change that to 14K, how does that change the answer? It doesn't change the answer at all, correct? If I changed R1 to be 16K, this R1 that is labeled there, what effect does that have? If I change that to 16K, that affects it here, which will increase my gain by that amount. Okay? So understanding how those affect the different gains. All right, any questions? Clear what is expected for you to know for op-amps? Okay. All right, the last type of problem means you have to understand capacitors and inductors and then being able to solve the circuit where it has a first order. So one capacitor or one inductor in the circuit. So we went through last time finding the solution, and we have that general form equation. So to do the general form equation, this is kind of a summary in my own words of how to do that. So you're redrawing the circuits each time. Time equals 0 minus, time equals 0 plus, time at infinity, and then you need to redraw it to find tau. And I forgot to put, so tau is R Thevenin times C for capacitor, and then tau is and then it's L over RTH for an inductor. The initial value is at t equals 0 plus, so that's another important thing to remember. Capacitor is open, and it's a wire for an inductor at time equals 0 minus, where it's sat for a long time, and then also at infinity, where it's sat for a long time. Right at the change, you have an effect, and that capacitor becomes a voltage source, and the inductor becomes a current source. So using that information as far as the characteristics of the capacitor and the inductor, you're able to then find these values, infinity and the initial, and then tau, and then you can plug them into the general form equation, which is an exponential. Okay? Okay. So for this one, it sat in position 1 for a really long time. So this is before the switch, it's been here. And then at time equals 0, it moves to position 2. Does that make sense? Okay. So time equals 0 minus, that wire will be connecting from there to R2. And then after the switch moves, it will be in position 2. So go ahead and try and solve this and get both VC and IC.
So my reading.
Oh, the whole thing, the whole thing. He does.
I did have more like I'm proud of you. Alright, I didn't have any governors. I didn't have any governors. Hey, it's an improvement. Three. No, three misses, one mistake. How? I literally just sacrificed it.
Okay, so you need to draw these for each of the different cases. So t equals 0 minus. Where is the switch going to be? Down, correct, thank you. So you're going to have a wire here. And what is happening with the capacitor? Okay, so it stays open. And there's nothing connected there. So your VC will be 0, IC will be 0 here. At t equals 0 plus, this becomes a battery of 0 volts. So it takes on whatever it just found. So at 0 volts, that's like a wire. So that's going to bypass the R3. And then, forgot to draw the switch, sorry. Switch is going to be in that position. And so the current going through IC is just going to be the same current here, which is V0 over R1, which is, what was V0? 12 divided by 30. By 30K. So you have 0.4 milliamp for IC. And VC is going to stay the same at 0. So those are your initial values. All right, questions on that? Yes.
Do you want us finding the current using a 0 plus time, or can we take the, once we get that final equation, the voltage over time, we just take that direct over
Yeah. Yep. So if you find the voltage and not go through these steps of finding it as you go for IC, that's fine. You can do C dV dt and get the current IC. And it would be the same. It should be the same. Okay. At infinity, the switch is in the second position, so it's going to be here. And it's sat again for a long time, so this is an open. So grounding this means that that voltage that's on the top wire that's here is going to be the plus side of the VC here, which is the voltage across the R3. So I can do a voltage divider here. And R3 was 60K. This was 30K, this is 12, and this is 60K. And R2 is 120K. So this then gives me 1230, 90, 4 volts. And then IC is open there, so IC will be 0 for the final value. Yes?
Is R3 60K?
Yeah.
So that's 30K.
R1 is 30K, R3 is 60K.
I think you have R3 as 30K. In the numerator.
Yeah, you're right, thank you. I see what you're saying. Okay. Okay, 60K. So this is actually not that. 1/3, 2/3, 2/3 of 12. 8 volts. Okay, so that should be 8 volts, thank you. All right, then we need to find tau. And for tau, we're going to do the final circuit. So that's going to mean that this is here. We're going to short the voltage source, and then our pathway is A to B between where the capacitor was. So our pathway here goes to R3, and then it splits. And so those two are going to be in parallel. So RTH will be R1 in parallel with R3, which is 30K in parallel with 60K. And tau will be RTH times C. So this ends up being 20K. And C was 100 micro. Three, 2, 3 is 2 seconds. So what does that 2 seconds mean? Correct. So it takes 68% to get to the final value. So it started at 0, and then it goes up to that final one. So final is 8. And IC of T had 0 as the final, and 0.4 milli is the initial. Over 2. All right, questions? Yes.
So you would get the same answer if you took the derivative of VC, right?
Uh-huh.
So where does the 0.4 milli instead of just regular 4 come from?
So this is 100 micro, and then you have -8, and then when you take the derivative of e to the minus t over 2, it's a -1/2 comes out. So it's multiplied by -1/2.
Oh, capacitance times that.
It's capacitance, yeah.
Yeah, I forgot the constant.
And that gives you the 0.4 milli. That make sense? Okay. All right. So for this one, I2 of t, solve that one for this circuit. So try and write that equation.
Yes, we should.
No, I was about to, no, I was about to go. That's how big it is. They're all used to see and that they weren't even next to each other.
So we had those right.
Yep, I don't think it'd be easy.
You just died. That's the real issue. That's all you need. Are you not chronically alive?
Yeah, what'd you say?
Rubber room.
What happened to
How does it work? I can imagine what I just can't imagine what he's
always did?
Zero, not just write zero. That's the current. So it's actually not a wire. But it should be a wire. No, the current is still a current. Yeah. So we don't need the voltage. There's the R.
Was it just the practice exam? Or no, not practice. Questions from class? Or it was just the
Okay, so for time equals 0 minus, this is still going to be open. Oh. And then the inductor acts as a wire. So there's no current flow there, so that still stays 0. For t equals 0 plus, this gets closed, and now this becomes a current source with 0 amps, which means that's going to be the same value. So this still stays as I2 is 0. If I was to try to find the voltage here, this would be the same voltage that's across R2 in this case, and that would be your initial value. For the final, this is closed again, and then this acts like a wire. That is annoying. Okay, so this is going to short R2 here, and your current is going to be the same current that's going through R1 there. So I2 will be IS times R1, RS over R1 plus RS. And that's your final value. Tau then is going to be, so for tau, remember, you're going to take out the element and put A to B on the locations of the sides of it. So A to B, this is going to go and split, and then this one goes through. So the RTH will be R2 in parallel with R1 plus RS. So you'll plug in these values for each of those. Tau is L over RTH. So your tau is L divided by R2, R1 plus RS, all over R1 plus R2 plus RS. And then you would plug those into those different locations. Questions? So from here, once you find I2 of t, which is IL, you can find VL of t by taking L and the derivative of that. Or you can find the initial value and final value as you go through. All right, questions? Okay, so homework is extended and quiz is extended to be due by Sunday night. So quiz will open up Saturday and be Saturday and Sunday. Okay, see you guys on Tuesday. Good luck.
Yeah.